printed document, we consider even handwriting also. Look at handwriting here. Handwriting, first of all, handwriting itself a tough job because you can expect a lot of variations, in writing and free writing style. So pen, ink, paper, so many variations will be there. So apart from that, now you are looking for some distortions introduced by forgery operations. Now my question is this one. So when the document is degraded and the document is maybe distorted because of some device problem or because of poor quality image or paper or something else. So now the question comes now. What is the big question here? Now you are thinking that what is our basis? The basis is something like this. When you perform some operation, there will be some distortion. So now, yes, there are some distortions introduced by forgery operation. There are distortions introduced by some noise, some blur, some other poor quality image or low contrast, something else. Now, yes, this is the big question mark now. Apart from that, in case of handwriting, now you can see different styles also and variations also. So what I'm saying here, forgery detection in handwriting is not so easy. It is really challenging compared to even image and video forgery. Here we try to alter even small 1 character, 2 characters. We don't change a whole paragraph or whole page. Okay, so that's what you should remember here. So there is a difference between general image forgery and handwriting document. In case of handwriting document, again you can look into two kinds of things, two types. One is printed document, another one handwriting documents. So handwriting document is really challenging, and of course we can find a lot of applications for handwriting forgery detection. That means forgery detection in handwriting. So okay, that's what you need to remember here. So first one, actually fraud handwritten document identification. I will try to explain. So what is the motivation and what is the work, and nationality. Okay, that's nothing but on identifying the nationality, which country he is from. Writer age. When you write something, automatically we should estimate your age. Is it possible? Forged handwriting. That means it is a handwriting. That means when you make some forgery while writing, or maybe when you alter something. Yes, how we can alter text. This actually here we consider PDF document. So when you use a PDF document, probably yes, yeah, you can use a PDF editor to make some changes. So those are the problems here. So now, so maybe I will move to the next slide. Yeah. Or I forgot something to tell. Fraud, okay, that's fine. Introduction is fine now. Yeah. Yeah, this is the first paper I am trying to discuss here. Of course, what I want to say, I don't know your background. Yeah, if you are really have a background of image processing, then it will be interesting topic. If you don't have a background of an image processing, or you don't know anything about image processing, then probably yes, it may not be very interesting. But in that case, what you have to do, you just try to understand what is the problem, how I am trying to solve this problem. That means the way I am solving the problem. So you just try to look at the way in which I am trying to propose something. Okay, so that means what I am saying, though your background is something different, no need to worry. You just look at how I am solving the problem, look at how I am proposing the solution, and really how we are trying to get some ideas to solve the problem. Okay, so I think that is more than enough for you. So this is what introduction. Yeah, I think fraud document, I think now we can see a lot of applications, especially I don't know in Kerala or somewhere else, but in Karnataka I have seen so many scams, especially descriptive answer evaluation. That means in evaluation. So I have seen in many cases in Karnataka, so people try to change whole manuscript. People try to replace the script by another script, or maybe the forged one. So like this, we can see a lot of scams also. Even I heard that there is one story. I don't know, maybe you can search now. You can search in Google also. Probably you can find that paper. So I was just reading one newspaper. So what was the incident? I think in Karnataka there is the international airport, right? So here in Bangalore, what is happening? Unless you have a valid document, the security will not allow you to enter airport. That is in beginning itself, and a security will check whether you have a valid ticket, and of course you will check with your identity card also. Then only the security will allow you to go inside. But actually one guy, what happened, one couple, actually what happened, what he did, actually he wants to send his wife and kid to somewhere else. But the problem is they have to carry a lot of luggage. And of course, when there is one small kid also. So what this guy, intelligent, smart guy, so thought, okay, maybe I will try to enter airport to help her, to help his wife and kid. So maybe he wants to just go to near to the counter, and then he wants to come back. That's what in his plan. So what he did actually, of course, he is a frequent traveler and he used to use in the same airline, same times, everything. So what he did actually, he used his old air ticket and he modified exactly the date only. That means he changed the date because the same airline, same name, everything is same. He just has taken in the previous air ticket. So what he did actually, he just changed the date. Yeah, then finally what happened? Yes, he came with a modified and the forged air ticket, and of course, wife and kid have genuine ticket. Now, of course, security could not notice because it is just a date only. Of course, security will check only your identity card, maybe timings. Yeah, that's all. So after that, he will allow you to go inside. So this guy, what happened? He went inside, and of course, yeah, after taking after clearing all the things, and of course, he wants to come back now. He doesn't know. He doesn't know. That means he never anticipated what happens when he start going back. He did not imagine. So because just he was thinking that how to go inside. He doesn't know how to come back. So what happened after family flying? Then immediately started coming towards the exit. Then security caught this guy, because unless you have a valid certificate, valid ticket, you cannot enter. That is a rule. That is a security. Now what he did? Now he cannot come back because whoever entering into the airport, they should fly. Nobody can come back. So that is a rule. That is what the procedure. Now this guy is coming back. Now immediately security caught. Then see. Then of course, so that guy did not reveal his intention in beginning. Then slowly, of course, you know very well that how police can get any information. Then immediately he explained the reason. Then he told police that, okay, I just changed the date using PDF editor. See, just a small date. If you change in one small date, you can do anything now. So though it is very small, but it is really very dangerous. So security breaching. Okay. So like this, and I can explain many applications anyway, not necessary. Just I'm trying to explain the importance of problem and the forensic applications and handwriting document applications here. So like this, even suicide note also, I have seen in many cases there will be a lot of suicide. One will be genuine, another will be a created one. Like this, even police cases also I have read and many in the newspaper in Karnataka. Okay, so there will be a suicide note, one written by actually a girl, or another one is actually created by police or someone else. So now how you can differentiate? How you can see it as a genuine? Of course, there is a simple way is you can check in your handwriting. You can go to the school, you can go to the master, you can go to the teacher. Probably you can cross check to confirm which one is really genuine handwriting or forged handwriting, something like this. That is anyway a different story. That is a job of a forensic investigation, forensic team. But as a researcher, I don't want to go in that way. What I should do without taking help of forensic team, is it possible to say that this is a genuine document, this is a fake document? So how it is possible? So that is actually the applications here. Even answer script also, I have seen in many cases. So what is happening here? Assume that the guy write an answers, and finally, of course, everyone knows that will be stored in a storeroom. Usually they stack in a particular room or something. So intelligent people and in a crime, the criminals, what they do, they will try to open the storeroom and finally they will replace with some other document. So we have seen so many cases in Karnataka. So now the question is something like this. There are two cases now. One case is actually suicide note. Another case is like an answer script, replacing a new answer script with a old answer script. Now you tell me how you can say that this is a genuine and this is a fraud one. How you can say? This is the problem here. Okay. So okay, that is a problem probably. Next paper, next method. So I will take in this one as a problem to propose the method. Okay, like this, fraud answer script and certificate to marks cards also, bank document also, security documents also. There are many now. Of course, literature survey, I don't want to go in detail because let us cover in my own methods first so that we'll get some information. So literature survey, no problem. We can go through any papers or you can Google automatically, you'll get in many papers. So yes, if someone is interested, probably is let him go through the papers to know what is the state of the art. Now I don't want to spend time in explaining literature survey. So now just I just highlight the point here. So most of the paper, what they're doing, they try to check in ink quality and some distortions, probably the distortions at the edges and maybe some alignment problem, and foreground in the sense in the style problem, variations in the handwriting. So like this, they try to check a lot of, they try to extract a lot of features to identify forged documents. But in my case, it is not that we should depend only ink or ink or foreground information. So as I mentioned earlier, there are two cases now. One, there is a suicide note. Another one, answer script. Now assume that a whole page is replaced. Whole page is replaced now. So you don't, it is not that any in the document, within the document, there is small change or there is a small alteration. No, whole document is forged now. So whole page is forged now. Now you have two things. One is a document, fake document, another one genuine document. Maybe it could be from an answer script, it could be suicide note now. Now you just take these two examples. So now tell me how you can solve this problem. Okay. Yeah, this is what the literature survey. So literature survey, most of the time, they depend on the content of the image, and probably the global features. They'll try to look at global features like this. Okay, what is happening in a whole document? Okay, rotated document, or some kind of an alignment problem, or line variations problem, or word variations problem. Like this, and they'll try to look for global features. Of course, this will not work when whole document has been replaced by fake document. Because within the document, if you find something, yes, if there is some alterations, if there is something tampered information, then it is possible. Now, whole document is replaced now. How? So I don't want to depend on the content here. Maybe content can be English, content can be Malaya also, even any language. I don't mind, I don't care. The document contains only this language or this script or something like this. So irrespective of the content, paper quality, so somehow under ink also, handwriting also, so we should say this is a genuine document, this is a forged document. How it is possible? Okay. So yeah, now this is the idea now. So okay, let me ask one question now. So now I have been telling that I have been referring in two cases now. So one is suicide note, another one answer script now. So look at my sentence now. So what they do, if you want to create a forged one, what they do? Assume that before creating you'll have one original one now. So that means earlier you already have an original one. That means you already have an original one. Now after getting the original one, you will try to create one more now. That means what is happening now? There is a time difference here. So first one is old one, fake one is actually new one now. So when you have two cases now, one is original, one is a fake one now. So for me, fake is new, old is original now. Now my question is, without analyzing the content, without even expecting any distortions, without knowing the content, somehow I need to say that this is old one, this is new one. How we can say? What is the idea here? Probably I think many of you got an idea now. So what I'm going to do now? So that is the basis here. That is the idea here, because time makes a difference here. So since it is a old document or old page here, definitely we can expect a poor quality here. If it is a new document, definitely you can expect a high quality here. If it is a high quality, definitely you can do so many things now. If it is a low quality, definitely we can expect some loss of information here. So why are you depending on only text? Why are you studying only text information and stroke information or ink information or this information, that information? Even any language doesn't matter, because you are looking at a quality now. Whether it is a poor quality, whether it is a high quality. If it is a poor quality, it should be original document now. Because everyone knows that when do you create this fake document? After original. That means original is always old. So this is the idea we used here. Okay, I think that's the point, and you should remember here. So actually, yeah, this is what you should remember also. Being a researcher, how we can get an idea. This is also very important. I think I have given many talks on how to write an articles and how to generate ideas and how to sustain a problem. I have given many talks and in many places. Now this is actually just I'm trying to explain just one sentence here. How do you get an idea? It is not that something and you are getting an idea from the heaven or from the sky. No. You have to, your mind, it's all your mindset, it's all your thinking only. Now see, when I was reading at the same time, when we were solving this problem, at that time only, I was reading this newspaper. I think everyone knows that the Malaysian flight and what happened when it was flying over Ukraine country. So that was a war between Netherlands, Russia, and other Europe and countries, right? Yeah, there was some problem. So now what happened? Anyway, I don't want to explain what happened. So, but now, see, interesting point here is that what happened after the incident. Netherlands people came to the exact spot. They collected every piece, because they don't know what happened, what force hit this flight and airline. Nobody knows that one what happened. Nobody knows in what is the force. Nobody knows where it was hit. So nobody knows. Then how you can identify? See, interestingly, what they did actually, Netherlands people, technical people, the whole team has come to the place, exact spot. They collected small, every piece of information. Now, you know what they did? That is the point, and that is the interesting idea here. After going back to their place, they try to assemble small pieces. See, when you are reconstructing, now they are trying to reconstruct the whole airline now. So when you are reconstructing whole airline, automatically you can understand that where is the gap now, and what is missing here, where it is missing here, and even what force hit by, something missile or something else. See, that is the idea. Just I was reading in the newspaper only. That's what I am telling here. This is the way you people should get idea. Of course, if you are really a researcher, if you are really doing some PhD or maybe, then definitely this is the way one should think now. One should think. So now, of course, I'm reading a newspaper. Just our mind was thinking, because at the same time I was doing this problem. So we are trying to propose some problem, some solution. So immediately we started thinking, can we apply this kind of method now? That means what is our idea now? So we need to split now. That's what idea now. So there is something. Now you try to make it many pieces now, divide into so many things now. Then finally, you try to combine now. Of course, before combining, you do something. That is up to you. That is your job. Okay. But what is the idea here? Idea is something like this. Okay. You divide something into so many pieces and finally you combine. Definitely, you can identify what is wrong with the reconstructed one. Okay. That is the idea. So what we did here, this is the idea here, what we did here. So of course, we used in here Fourier coefficient, Fourier transform. So we take input image. So then we apply Fourier transform, and of course which gives in positive and negative coefficients. That means we are trying to divide coefficients into positive and negative coefficients. Here anyway it is easy. Of course here we don't take an imaginary part, we just take in the real part. So with the real part we are able to classify, okay, these are the points, these are the coefficients are positive, these are the coefficients are negative now. Okay, now with the positive coefficients we'll try to reconstruct the image, with the negative coefficients we'll reconstruct the image, and finally we combine. This is what reconstruction after divide and conquer. Before it is original image. Before reconstruction, it is original image only. You are just applying for a transform to get any reconstruct images. Okay. Now my point is this one. So what should we do now? Okay. I will try to divide. I will try to classify positive and negative coefficients, and then I just reconstruct using only positive coefficients. I reconstruct image using only negative coefficients, and then finally I will combine these two as a one. Okay. Now what happens? See, this is the idea now. See, so this is a old or input. Anyway, for this work, what is the input now? One old document, another one new document. That means one genuine, one fake document now. So my job is to say that this is the old document, this is the new document. In the other way, we need to say that this image has contained poor quality, this image has a poor quality, and this image suffering from poor quality, and this one is a good quality. So that is what in our job now. So positive and negative coefficients now. So I am trying to reconstruct, and finally I use in both the images to get one final image here. Of course, this is a reconstructed before divide and conquer. That is nothing but a what? Input image. Okay. Now I am trying to analyze now. What is the idea here? You tell me now. Of course, with this diagram, if you understand idea, and the next step is very simple. Just I will move in slides, so no need to explain many things. Now, what is the idea here? Okay, just now try to analyze now. So let us take a new document as input now. So what happens now? New document, right? Okay, new document now. Now you are dividing into positive and negative coefficients now. Using positive coefficients, again you are getting the reconstructed images now. What happens in the reconstructed images when you take new document as good document as input now? Do you think there will be a difference between input and output images? The final output reconstructed images with input images, there won't be much a difference. Why? Because the new document, it is a new document has a high quality. So when you have a high quality, what happens? So when you are classifying positive and negative coefficients, I think nothing will happen here. So most of the pixels, of course, the positive coefficients generally represent what? Age information. Negative coefficients represent generally negative, what is the dark and background information. Now what is happening now, since it is a good image, so high quality image, all the pixels which represented by positive coefficients will classified into yes, one cluster or one group, and similarly negative. In case of old documents, what happens here? Old documents, it is a distorted image now, poor quality image. When image is when image is suffering from the poor quality, when you are classifying positive and negative coefficients, definitely you can expect some of the coefficients will be misclassified, or some of the positive coefficients will be classified as a negative coefficients, or some of the negative coefficients will be classified as a positive coefficient. So when you reconstruct this kind of coefficients, when you reconstruct the image using this kind of misclassified coefficients, then definitely there will be some reflection in your final reconstructed images for old document. See, that is the whole idea now. So what we are expecting now, when you compare with the new input document, there should be a big difference. If it is a new document, there won't be much difference. If it is a fraud document, if it is a old document, there should be a big difference. That's the whole idea. Now we solve the problem. Okay. Yeah. I think yes, that's what I explained already. Yeah, this slide should explain that one only. Okay, these are the examples now. This is actually the whole document now. See, this is actually Fourier transform. This is a positive and this is a negative, and this is actually fused one. That means in a reconstructed one. This is a positive coefficients. Okay, using positive coefficients, we are reconstructing this one. This is negative coefficients. Of course, we cannot see information. Positive. This is actually see RADC. That means in after reconstruction. This is before reconstruction. See, this is actually whole document. There is a difference now. What is the difference here? You cannot see information. Here, right? So here, of course, it's the input image. It's exactly input image only. You can see some information now. So this is a new image now. So what is happening? This is a new image. This is for new image. This is after reconstruction. This is before reconstruction. So try to compare with the new and old now. Old now. So new probably yes, it will be a little bit brighter compared to old reconstruction. And this one. Anyway, there should be a difference. But how you can visualize this difference now? So for this, what we did, maybe I'll just go to the next slide. Look at the scanning edge images. And one more thing you try to observe here. I am trying to use Fourier transform here. That means, see, my belief is something like this. So according to my experience, when I see something in the image from my eyes, definitely I will try to think of spatial domain based techniques. If I cannot see clearly some difference in the image, that means from my eyes, then definitely I will try to prefer frequency domain based techniques. That is what just my experience. That means if I want to propose some spatial domain method, then I will try to see something from my eyes. If I'm able to see in the image the difference, then yes, definitely I will try to propose or try to think of spatial domain methods. If I cannot see, then definitely I don't want to depend on spatial domain. I don't want to use any spatial domain. I will try to use frequency domain. Why? Probably image processing people know very well. Frequency domain is really sensitive. The coefficients are very sensitive to small changes also. Very sensitive to the changes. But of course, negative coefficients, there will be another problem. There will be a limit. There will be another drawback of a negative frequency domain. There will be a lot of noisy coefficients. So you should be very careful. Simply, we cannot use any frequency domain. Yes, you need to know when you can use this one. So for which application it should be correct. Okay. So now, because anyway, here the whole document is changed now because I am trying to analyze the whole quality of the whole document. It is not that an only particular portion or a particular image or a particular character. So it's fine for me. So now look at this one now. So time, I don't know. Sometimes I take too much time. So maybe madam should send a reminder. So then yes, I will try to pick up in my timings. Okay, now so canny and this one, look at this one. This is canny edge of RBDC means before reconstruction, after reconstruction. Okay, RADC means this is actually new document now, before and after. So I don't think there is a much difference here. There is a difference, but not really much difference. Look at this Sobel now. It is canny and Sobel here. So what is happening now? So we are losing information here. So this is actually new document, right? So actually there is a loss of information here. That means when you compare these two, there is a difference here, big difference. When you compare these two, not much difference. Okay, now look at the whole document here. Here, look at these two, too much difference. Even I can't see what is happening here, what is happening here. But here you can see almost same. So now, see what is happening. That is also a very interesting point here. The canny, I think you people know very well, canny edge is very sensitive to background, but Sobel is very sensitive to contrast information. If it is high contrast, no problem, we can get in a good edges with Sobel. But canny is not like this. It is, even if background is very complex or background is something in poor quality, you'll get a lot of erratic edges, spurious edges. So now what is happening, when case of an old document, you can see a lot of difference between after and before, especially for old document. Okay, now that is what an idea here. So what we are expecting now, very simple condition now, when you compare these two, so this difference is less than this difference. No, I think greater than. So because Sobel is losing a lot of information here, not much difference here. So this difference between these two should be greater than difference between this one. Okay, so if this condition satisfies, then we can classify it as a new document. So if it is otherwise, it should be old document now. That's a simple idea. Of course, now, yeah, you can propose your own algorithm. So what is very interesting here, I tell you, so this observation is very interesting. So this observation is very interesting. Once you confirm this observation, then you can propose your own algorithm. So since I am coming from image processing, and of course we are familiar with the canny and Sobel edges, we know very well that how this canny and Sobel behaves for different situations. So just, and of course it is a conference paper, so I did not think any other things now. So probably now you can change, instead of using a canny, yes, you can use something else also. Maybe you can extract straight away some features from this and from this images, and then you can propose some deep learning also, or you can bring some classifier also. That's also another way. Okay, but anyway, this is actually we targeted just conference paper, so we did not think too many things. Of course, we already extended this work for some other journal, but this work is limited to only simple work. Okay, this just condition we used. So finish. That's all this work. Okay, now it's all just experimental study. I think no need to focus on experimental section, because not necessary. Once you propose any method, definitely there will be some experimental results to validate your proposed methodology and prove that your method is effective or useful or something. That is common for every paper, every researcher. So every research. So no need to spend time in explaining. Of course, just look at the slides here. This is actually 5-class classification problem. This is actually our data set, and this is actually benchmark data set. So look at this. So we have used this benchmark data set. Why? Because we need to prove that our method is independent of content, works and does not depend on content of the image. Content can be anything, because we are trying to analyze the quality of the image. When you're trying to analyze the quality of the image, then content doesn't make any difference. It can be any. So it can be long way, it can be script also, it can be image also, it can be figure also, it can be picture also, whatever it may be. So we don't mind. So actually this is one data set is available. So they are actually classified like in a 13 decade and 14 decade, something like this. They classified. Oh, this actually again 1, 2, 3, 4, 5 class classification problem. So we have just tested our method on this data set also, because it's a benchmark data set. We need to show. So because when data set created by your own, then people don't believe, people don't appreciate your results, because it is your data set. When you create in your own data set, then of course, so definitely you will show good results in the paper. You will report very good results. So nobody believe that result, nobody appreciate that result, because it is your data set and it is your method. Definitely there will be a good results. So nobody believe that one. So if you want to say that yes, our method not only works on my own data set, it works on benchmark data set also, then people believe that your method is really good and works well for your own data set also, even benchmark data set also. Okay, that is a point you should remember. Unless you show your method works on benchmark data set, then I don't think people appreciate your work, and I don't think you can get acceptance. Now I think it is very tough job. Now the competition is very high. So many people are working on same problem. So it is not so easy to get in the papers. Okay. So anyway, these are all just some results. What else? I think, that's all. Next one. So handwriting analysis of nationality or ethnicity identification. This is also, maybe just look at this paper. This is the one. This is actually, okay, this is the one. Now maybe you can see this paper. This is actually, these are actually project students. Generally, I publish a paper, conference paper with project students only. When the project students join our group, then we will try to target one conference paper. We just don't ask them to do some work. Whatever they, of course, we always assign some good work, some research work. So we'll try to extract some work from the students. Then finally, every project student should have one paper at least. So of course, if they're interested, then we'll go for a journal also. I think that's what in our rule also, that's what our target also. So this is actually students from Mysore University. So project students only, these two students, and he is actually my student. Okay, that's fine. Yeah, I think so that's the same work. Just glance it. Yeah, this is the one work. Okay, this is the one piece of work. Next. Okay, next, handwriting analysis for nationality. Yeah, see, can you imagine? With the help of handwriting analysis, is it possible to say that this guy is from this country? Nationality identification. So you don't find many papers, or probably can find only 1 or 2 papers. Okay, what is the idea behind? That's you need to understand here. What is the idea behind? So of course, here you look at these samples now. How many? 1, 2, 3, 4, 5 classes. Okay, so Bangladesh, China, India, Malaysia, Iran. See here, what is the input here? First, you need to understand what is the input here. Okay, it's a very interesting topic. I think many people appreciated when we presented this work in the conference. I don't know which conference, 2018, yeah, ICPR. Yeah, many people appreciated. Not only appreciated, it was something like a shocking news and a surprising, some kind of shocking for them. So see now, what is the input here? English text as input, not their own script. Okay. So now look at the Bangladesh and Chinese here. What is the idea behind? So can you can you imagine? Can you think something? Can you get something in your mind? How you can identify his country by analyzing his handwriting written in English? Okay, he writes in English. He writes in English, not his own script, not his own language. That is the input for you. Yes, idea is something like this. Okay, you look at the Chinese. Of course, they used to practice Chinese, right? Because their mother tongue is Chinese. Of course, we consider only the people who have a practice of writing, writing with their own mother tongue, their own languages, not like in a different one. So that means Chinese. Okay, assume that they used to write Chinese. They usually practice Chinese. See, when we ask the Chinese guy to write English, what happens? There will be some changes in English writing, right? Why? Because look at the Chinese character. Generally, I don't know whether you people know Chinese script or not. They try to write. So look at their alphabets and the style of writing. They try to write in boxes, rectangular boxes. One rectangular box, within that there will be one more rectangular, within that one more rectangular. That means, so what I'm saying here, look at the strokes, it will be something like an horizontal and vertical straight lines, like in some boxes. So that means they have a habit of writing in boxes. They have a practice like this. So when you have this kind of practice, of course, when you ask him to write English, there will be a same kind of strokes in English also. But look at our Indian. Look at all languages, including Hindi, everything. You take any languages. All Indian languages are cursive in nature, not like in a straight line and vertical line, horizontal line. So when we ask an Indian to write in English, definitely there will be some reflections, because we used to write in so cursive characters. Then definitely there will be a change in English writing. So Malaysians, yes, we know Malaysia, there is no script actually for them. They try to use English as a script to write something. So they don't follow any shape. They don't follow anything now. So they write whatever they want. They like whatever they like. They simply write it. They don't follow even spacing also. They don't follow even a line orientation also. They don't follow anything, because these people don't have a practice at all. If you take any project on handwriting analysis here, nobody appreciates, nobody gives any value for handwriting things. Why? Because they don't write anything. Now even look at now. I think even classroom also, here in classroom, nobody go with a pad or something. Usually they go with the iPad or something, laptop or some smartphone only like this. So when they see some important slide, they'll try to capture only. Nobody writes anything on the pad. Nobody takes, first of all, any notepad into the class. Okay, that means these people don't have any practice writing. Of course, Indian, you look at the Indian, usually we start with, if we, when we were a kid, usually we used to write in copywriting. See, that is the way we used to write, and that is the way we used to learn the things. But anyway, so what my point here, definitely there will be a reflections, there will be changes when you ask the people to write English. Okay, that is what we are expecting here. Okay, see, Iranian, this is actually something like it's maybe like of course Farsi. That is a language exactly look like Arabic. So Arabic is something different. So when you ask Arabic guy to write English, there will be some changes here. So those changes we are trying to extract for nationality identification here. See, so anyway, applications are same, so no need to repeat the same applications, because for all handwriting forensic and all handwriting problems, I think there will be same applications. Only the change is small difference. Okay, what is our idea? Okay, now, so look at this one. This is the document. Okay, where this is the input now. So we try to remove lines, actually the ruled lines here. So because that one is not good, especially in handwriting, because when you're going with the components, because of the line, it connect all the words, so it will become in one component. Whole line will become one component. So we don't want to go in that way. So if we go in that way, we lose information. So that's the reason we try to. It's a pre-processing step. We will try to remove lines, ruled lines. Okay. So now that is a noise removal and line extraction. Okay, finally you get a lines, and after getting the line, so again, see, maybe you can observe one thing in my work. So most of the time I use Kms clustering and canny and sober edges, especially for conferences, because I don't really propose something totally different. So when you have a beautiful idea in your work, and of course when the problem is new, when you have something new idea, that is more than enough for conference. So we don't really introduce something very big for classification. Okay. So now see what is interesting here. So I take in a canny, and this is something interesting here, cold features. So probably I will explain what is that cold feature. Next slide, or next slide, I don't know. Anyway, next we'll try to extract some shape here. Cold gives in some shape here, like in distribution. So we try to extract, this is actually invariant. We are trying to extract an invariant features from this distribution, and finally we use in a classifier. Now, of course, if you use an SVM classifier, nobody will appreciate, nobody will accept the paper. If you bring any deep learning within this framework, then people accept and people appreciate your work, and of course it will be accepted in the conference. Okay, please remember this one. If paper does not contain deep learning things in your paper, at least something, maybe just use deep learning as a classifier. That is okay. Okay. See, if paper does not contain deep learning, then you don't expect any positive outcome from the reviewers. Okay, that's just my experience I'm sharing. Okay, yeah. Now, so text components, because I want to get in one component like this. So line, yeah, line is because of the line. So this whole thing will be connected and gives as a one component. So we try to remove this line. Of course, removing line is a very simple step, and you can find many papers because it's a very old topic. So yeah, maybe just you can guess it. Just first try to intersection point. So try to cut at intersection point. Try to first detect the intersection point, then cut it. Okay, when you cut it, then it becomes isolated line, the independent line. Now you just use some angle information, horizontal, this something in this straight line information, yeah, to remove. Okay, that is anyway. There are many methods you can use in segmentation. Also, we can use an active contour. Also, we can use many things, even color also, spacing also, cursive also. Yeah, many things, many features we can use. But anyway, now for us in this work, removing line is not very important as a contribution. What is important? Nationality identification is important. That means the classification is very important here. Okay, this is a pre-processing step. So we are getting some components here. Okay, this is the output now. So after removing the lines. Okay, now, yeah, canny. Yeah, this is actually canny edges. Okay, this one somewhere else. Yeah, okay, yeah. Now this is the canny edges now. Okay, what is the idea now? This is what the contribution in this paper. See, this is the one character now. So we are trying to get any canny edge image. Now this is the idea cold. This is a cold distribution. Cold is nothing but a what? Cloud of line distribution. It is in a polar domain. So again, see, it's something different domain, not really spatial domain. So I always like some other domain, not spatial domain. Spatial domain is very sensitive. It will not work for complex background, low contrast, and poor quality. So that's the reason generally I prefer all the time, most of the time, frequency domain. Okay, or some other domain, polar domain, or different space, color spaces like this. Okay, now look at this one. So what happened here? We just traverse this contour to identify or to detect the dominant points. This can be done using many ways. So we can traverse the contour to identify the cursive nature. So whenever you see some cursive, whenever you see some curvature, yes, automatically you can fix that as a 1 point. Okay, or maybe you can go with a polygonal approximation. So just in a polygonal approximation, automatically it gives in some points here, because polygonal approximation is something like a fixing boundary, fixing bounding box for this character. So that automatically gives in some points here. Now the question is this one. Just we are trying to get in a points. Once you get the points, we'll try to pass this distance between this and this point, neighbor points. Okay, so automatically you are getting the theta, and this r is actually the radius now. So R is row, yeah. So finally, what happens is a distance, right? Absolute distance, x, y. Okay, this is a, now. So you are getting in a cold distribution. This is a polar domain. Okay. Now for every, what is the input for this one? So distance between these 2 points as input for this formula. So automatically you get a cold distribution here. What is the speciality of this cold feature here? So that is what you need to understand here. If more straight lines, if you're giving in more straight lines as input to this one, you get in a dense cluster towards center at center point. Okay, if it is a too many cursive point here, cursive point, that means in this cursive edges, then you are getting in a scattered distribution here. That is a beautiful property of cold information, cold distribution here. So that means the distribution depends on the distance between the points. Of course, if you take only few points, then you may not get any difference here. So that means what I am telling, deciding these points, deciding the distance between the points is really very important here. Okay, if you propose, if you estimate and if you give a points with a large distance and a large distance, then you will not get a very good result here, because you are trying to understand the shape of the character now. So of course, if you just with a few points, you cannot understand the shape of the character. Even just more points also no use. More points also no, it's not useful. Okay, there is no use. Why? Because more points means you are giving so many straight points, and more cursive, that means what? Again, you will lose some information. Okay, that is the idea here. That means if you give a more straight line as an input, you are getting dense cluster at center point, at centroid. Okay, and if you give cursive edges as input, then you are getting the scattered distribution. Okay, now look at this one. See, this is a Bangladesh, this is a China, and this is India. So look at the distribution now, the cold distribution here. So Bangladesh, see, something is scattered in the sense what? More cursive in nature. So China, more straightness and straightness and horizontal or vertical, like straightness is more here. So you can expect in a dense cluster at center point here. Something in India, it's a cursive again. So some scattered. Here, Iran, yes, we don't know. Sometimes they write like in Arabic, right? It will look like Arabic, sometimes in vertical, horizontal. And Malaysia, we cannot predict anything. So we can expect any kind of distribution here. Anyway, what we want, so cold, that is a contribution here. Cold can give some difference between different script here. Okay, that is the point here. Now it is up to you. So once we get this distribution, now you extract some features or include some conditions to classify. So that is up to you. Now you just think, if you are expert in image processing, you just bring image processing things. If you are expert in statistical analysis or something else, or maybe data mining, or maybe machine learning, or anything, artificial intelligence or knowledge base or this one, that one, yeah, you can bring any technique now, no issue. Okay, now, yes, it is all in a very simple simple feature extraction we used here. Cold, of course, we want to propose invariant features. We don't want to use, simple features, simple means invariant features here. So this is a distribution now. This is a one shape for me. Just we go with the principal axis. That means maybe major axis. So with the major axis, definitely we just estimate the distance between this axis with respect to some points here. Whatever the points you are getting now. So just principal axis from the point on axis and point of this distribution. So distance between this one. So anyway, idea is this one. So using principal axis, this is a reference point. From the reference point, we are trying to estimate distance between reference point and distribution, pixels of the distribution. So anyway, this is actually invariant to rotation, scaling, and even translation also. Why? Because we are going with the principal axis. Even if it's a different rotation, yes, we are going with that rotation. That is a reference line now. So yes, now yes, we extracted some features here, and then it is easy. Just your send this feature extraction to your SVM classifier, automatically it will classify. So now, of course, if you want to change this classifier, you can change the classifier. You can bring now what else? Deep learning also. For deep learning, no need to extract any features. You straight away give these distribution as input for your deep learning. Automatically deep learning extract features also, even classifier also, end-to-end system. So automatically you will get a very good result. Deep learning gives a very good results. So maybe I think that's what I think we have already extended that work. Is okay. Now this is sample results. Anyway, I don't want to spend time in explaining experimental result. These are the sample results, and this is the classification rate of this is a proposal method of classification. Okay, this is existing method. The existing method does not work. I don't know what is this method. Okay, now yeah, that's all. Now just look at the paper. Yes, see, this is the one paper. Actually, he's from ISI Calcutta. So he's a Calcutta with, he's actually collaborator, Umapada Paul. So, and he's, yeah, from Nanjing, no, Hoha University, okay, yeah, he's China. Anyway, he's actually, yeah, he came for a project work. So yes, he did something. You just glance it. This is a one simple conference work. Okay, so you'll get some idea. Next one, age estimation. Okay, how we can estimate the age? This is also a very interesting application, especially immigration department. I don't know in India, but in Malaysia, what is happening? So yes, if you look at the Chinese, it is very difficult to predict their age, especially female. Male, okay, we can predict, we can estimate, and you can predict in somehow. But female, it is a very tough job. Though it is a 60 or 55 above, it's impossible to say that in 55 and 60. So yeah, that's I'm just telling one simple application. Yeah, it's very tough for you to estimate the exact age of the person. Okay, by looking at a face information or face reduction, face recognition, or even behavior, even hair, anything in skin also. There are many works for estimating age using skin also, biometric information also, even behavior also. So many things are there, but still, according to my knowledge, according to immigration people, yes, all those methods, all those techniques fail many times, especially for female Chinese female. Okay, just it's the information, it's not with any other things. Okay, now what is the idea here again? That's what I am saying here. Though your background is something different, no need to worry about any concepts here. So maybe for a transform, this is actually general transform, anybody can understand. So at least you try to understand how we are getting the idea, how we are solving the problem. That is more than enough for you people. Okay, and what is the problem? How did you take this problem? Whether this problem is interesting or not. That is the first point. After deciding it is interesting problem, then how we can solve the problem? What is the observation here? Simply we cannot propose some algorithm, right? So you need to have something. You need to observe something. You need to have some basis, intuition, basis. Something should be there. So if you don't have anything, without any intuition or any basis, simply if you propose any methodology, then nobody will accept. It is something like you're blindly proposing some method, you're giving some input, you're getting some output, but you're not sure what is the relationship between input and output. But of course, if you get a good result, you just write it. Okay, this is a good result, we got it. Why did you get good result? You don't know. And even if you give some other input also, probably yes, a classifier gives you the same results. Yes, what is the difference now? So that should not be. So in the paper, always people think, yes, I think faculty, if any faculty joined this discussion, they know very well, without writing any evidence, without showing any evidence, without explaining what observation or what basis you used to propose this method, I think nobody will appreciate, no paper will be accepted. Okay, now what is the idea now? So what is the idea behind it? So this is anyway 1, 2, 3, 4, right? Only four classes you have taken here. So it is something like psychological things. When you are small, you just ask yourself only. When you are small, our mind is totally free. We don't have too many disturbance and too many thoughts, too many thinking, right? Or we just look at and try to recall our childhood. See, we used to free of mind, right? We can write anything, we can talk anything without fear, fearless. Okay, so when you have that kind of environment, definitely you will write with a focus. That means what I'm expecting here, when you are small, when you are a kid, that means age is small, definitely you can expect a good legible writing, quality writing. Okay, like this, when age passes and maturity increases, that is a problem with a human being, right? When you grow, when you are growing, then automatically you get a lot of disturbances. It's all psychological things, because responsibility increases, maturity increases, and responsibility also increases. So automatically a lot of disturbances. That means your mind gets any disturbance. So when you have this kind of environment, this kind of attitude and mindset, when you write something, definitely there will be some changes in your writing. Assume that this is a childhood writing. After certain years, again you write the same thing. Definitely there will be a change. So what that change? Change is some kind of variations. So probably here we can expect a good writing and good character and good shape also. Maybe when age passes, definitely you cannot expect the same shape and same force, same style of writing. There will be some changes here. There will be some changes here. That is what the point here. That is what the idea here. So that means when age passes, automatically there will be changes in writing style also. So that is what we need to extract. Look at this one. Again, I am trying to bring in a can here. So what is this canny? See, this is actually small kid, 11 to 12. 13 to 16. See, some you can see some kind of a distortions here, some kind of a variations here. Maybe you can say it's a disconnections. Here, good components, but here look at a lot of disconnections here. Here also some kind of distortions. Here look at compared to this one, this is too many. So that means what we are trying to confirm here. This is what the observation here. That means when age increases, automatically you can see a lot of variations and disconnections here. So disconnections, usually disconnections you can expect. It's true also, it's valid. Why? Because you don't write with the right focus. Because your mind is not stable. Your mind is not stable. So since your mind is not stable, unstable, automatically that will reflect when you write something. So definitely in one character, there will be good force and strong force. Another character, another word, there will be less force. And style also definitely changes. Okay, that is the variations here. So we need to confirm this one. So just you look at this diagram here. There's a graph here. So we actually we try to calculate aspect ratio of each component. That means this is a one component for us. This is a canny edge image. It's a connected component labeling. It's just we use in a connected component labeling. So we just take in component. For every component, we try to calculate aspect ratio. Aspect ratio is something like a height and weight. It is very simple formula. So now we just plot an histogram on aspect ratio. Okay, so this is the aspect ratio and frequency. This is a frequency histogram, right? See, look at this one. What is happening? Class 1, you are getting this one less variations. Why less variations? Because same shape, you can expect in more. That means what is happening when you take in components have almost same shape. Okay, so this less variations here. So that means you see age increases, variations also increases here. So that means not many components. See 0.5 aspect ratio, again some other aspect ratio, but here one is many aspect ratio, many characters. That means this document is better. Almost you can see same size. This one not same size. Again, this one is not same size. Why? Because of the disconnections. When character is disconnections means what? When character split into so many subcomponents, that means of course size varies, size changes now. Because small component size is different, but earlier actual component size is totally different. So when you have variations in sizes, automatically you can see this is what observation. See, this is what I observed from the canny. Now I am trying to confirm. Okay, like this you need to write in the paper. This is very important. If we without this diagram, if we just propose some algorithm, nobody appreciate, nobody accept your work. Okay, now what is our goal here? So we are trying to extract some dominant points. We don't need in all the components here. Okay. So we don't need in all the components. No, I think it's the text components. Okay, yeah. You try to extract in the components now. Here, what we did here, of course, there will be, see, it's a very interesting idea here. There will be some lines, right? There will be some lines. So we need to remove these lines. How we can remove these lines? See, for that we propose a very simple step. See, canny and this is a canny and Sobel, this is a canny and Sobel. See, we just try to extract intersection points. See, intersection point. So those are the dominant points. Just see, if we extract intersection point, then automatically we can eliminate the problems of this line, the connected line that's in a ruler. Okay, the ruler, yeah, line. So now intersection point. Again, what we do? Again, we intersect these two, canny and Sobel. So these are the actual points now, dominant points, not really lines or noisy, because it's an intersection point. When you get intersection point, when the line crosses, or some because it's a handwriting. So when you write handwriting, it's connected. So it's even every characters are connected. So there will be intersection point. Okay. So we don't want to take the one you draw. So we don't want that one. So just to remove that points which represent the line, so we just used in a very simple step. So canny and Sobel and intersection point, again intersection point, we call the seed pixels. Okay, now see, interesting, for each seed pixel we are trying to go back and restore the edge components now. So that means we know the point here. Corresponding to this point, we'll go here and try to get the whole component here. This is what the component restoration. Okay, grouping neighboring pixels. So that means we are trying to go here and try to get the neighboring pixels, because it's a handwriting. It's all connected. So one pixel is enough to get the whole component. Okay. Now this is the whatever the bounding box is refers to one component. Of course. Now what is happening now? We are trying to disconnected measure. Actually, this is a hue invariant movement. This is actually something like in your geometric and moments formula. Of course, a U invariant movement. This is actually proposed for studying or measuring disconnectedness. Disconnectedness. It is there. It's not in our concept. It is there. It's already there. Okay. Now we are trying to use this kind of concept. Okay. So now what did this formula expect in a pair information? So pair, that means S1, S2, these are the two components. We want two components. Then we will try to estimate the distance between these two components using the moments. So U invariant moment. Okay. Now it is just moments formula only. It is very easy. So this is a new measurement. Yeah. Okay. Now grouping the first nearest neighbor component, because this formula requires two components. So for that, what we did, so we just try to take one component and we'll try to look for nearest neighbors. Of course, you can expect an 8 nearest neighbor. So we take first nearest neighbor like this, and we're getting the one pair. For every pair, we calculate this disconnected measure. Okay, so that means we're getting some feature. Okay, we're getting feature. Now we did not use any classifier here. So what we used here, Kms clustering. So see, what is Kms clustering here? How it works here? Assume that, okay, it's a very good document, good writing now. When you have a good writing, if you apply Kms clustering, what happens? Not many variations, right? So when you don't have many variations, you don't get many clusters. That means in many iterations. Because when you have many variations, then you can expect many iterations. So that is the idea we used here. So Kms clustering as a classifier here. So that means for class 1, just 2 iterations are enough. Class 2, so then you need to go for at least 3 iterations and 4 iterations like this. That means, so what is the point here? See, forget about algorithm here, how it works, but what is the idea here? So when you have less variations, yes, less number, Kms clustering takes less number of iterations, requires less number of iterations. If more variations, then automatically Kms clustering takes many iterations. Okay, because as we observed earlier, age increases, definitely there will be a high variations. So when you have a high variations, definitely iterations also increases. Okay, yeah, this is now just an experimental results. So I think same, no need to focus on this one. Okay, just in a class 1, class 2, this existing method. Yeah, there are many standard database also, CART and IAM data set. These are all standard data set. Maybe yes, if someone is working on handwriting, he knows. Yeah, this is see, this student is actually from Mysore University. He just worked with me for his project work. This is all project work only, and of course some collaborators. Yeah, see, it's a very simple work. Any student come to me for their project, then generally we target some conference paper. I just set deadline only. They cannot escape from me. Okay, otherwise they should leave. So they should not come to me at all. Okay, now what is the next one? So maybe how much time I have? So 5:37. Maybe have enough time. Okay, now this is another one. This is actually very tough and very challenging problem, I tell you. I think in the conference we got very good feedback from the reviewer. Yeah, it was actually oral presentation, and I remember yeah, all three accept or strong accept or something. Yeah, I remember we got very good feedback. Of course, I was actually program chair. That's the reason I remember. So reviewer also I know, and I know the reviewer score also. I know the reviewer confidence also, because I am a program chair of this conference. So anyway, what is this one? See, this is something different. New forged handwriting detection method. Okay, again, it's a Fourier spectral density. See, try to observe, how I am solving the problem, how I am proposing the methods. That's also very interesting here. See, I am trying to discuss the same handwriting and forged detection only, but different way of defining a problem and different way of applying the same method on different issues. That is what researcher should think. That is the way research should go. It is not that you change your problem, change your domain. You always have to think in one direction and on working on one field. So see, that is what the research mind. Same concept can be adopted, modified, or applied on different problems. That is what the specialty of the researcher. Okay. Now, so this is handwriting detection. Okay. Now look at this one. This is something different. Again, the forensic applications are same. So yeah, what is the problem here? Maybe let's straight away go to this one. Not this one. Now forget why. Okay, this one. As I mentioned earlier, see, for forged document, what is the basis we consider? Forged operation introduces noise or some distortion. That is the basis. Now the question is this one. Initially, yeah, in the beginning itself, when I explained, see, when noise is there, then how? When blur is there, how? So that is what, we made this problem really complex here. It is handwriting, not only handwriting. We are trying to add some noise also. We are trying to add blur also. Of course, we use some Gaussian noise and Gaussian blur function. We don't get actual real images. Real images, of course, forged document is a very tough job. Maybe you should go to some research institutes to collect the information. Yeah, I don't know where we can get, but these are all actually our own data set. Of course, we always test our method on standard data set to confirm that our method is effective or useful. Okay. Now what I'm saying here, this is the one class normal, that means non-tampered, so we don't tamper. So this is actually original image. This is actually noisy, just we use original image to add some noise, and again we use some function to add blur to original image, and this is actually forged. What is forged? Maybe, yeah, they changed something, TMA, yeah, something anyway. See, LIO. Okay, this is a whole word is forged now. Now, how you can say that this is a forged? If we look at these two, do you think really is a difference? If we ask you what is the difference between these two, probably you don't notice this difference unless if I say this is actually forged. Unless you have a knowledge about this is a forged and this is the original, then you can notice some difference here. Otherwise, if I just give these two, I don't think they can notice. Of course, in these two, I think definitely there is some big difference here. Writing is some change, and writing is changed here, but that is what actually the problem here. So that means when you compare original and forged, you don't see any difference. That is what the people do, right? That is the way they try to forge it. That is a real scenario we need to consider. But now here, not only just these two, we are trying to add these two classes also. Now the question is, because we always assume that, so when you perform some operation, it introduces some noise or some blur or something here, some distortions here. But so that's what we assume also, that's what we believe also. Now you look at some noises here, some distortions here, some distortions due to blur. Now how you can differentiate this distortion is different from these two distortions? That is the point here. That is an interesting point here. So that is a challenging here. So that is a challenge here. But what we assume here, look at this one. See, as I mentioned here, noise. See, noise, we are adding noise using some Gaussian functions. Again, blur we are adding using Gaussian functions now. See, look at the word Gaussian. That means when you add this noise, definitely it satisfies some regular pattern. That means we can expect some consistency, some regular pattern when you add a noise using some default or known functions, because it's a Gaussian. Gaussian noise means, yes, there should be some meaning to that. It should follow some criteria. It should follow some procedure. So there will be definitely some pattern, something known pattern. Again, blur also, there will be some known pattern. But what about this distortion? This distortion definitely one cannot predict, because it all depends on the person. It all depends on the operations. Here only one operation. Here, no, it's not one operation. So now the question here is, yes, it depends on the person, how you perform the operation. So this is actually unpredictable. That means arbitrary operations, arbitrary pattern. This one, some regular pattern, this is also regular pattern, but this one, we don't get a regular pattern, something arbitrary pattern, random pattern. That is the idea. Okay, that is the observation here. So, okay, that is the basis here. You should remember that is the basis now. Now we are trying to extract the features now. How we can solve the problem? Again, we are trying to use a Fourier transform. Okay, this is a Fourier transform. Of course, from Fourier transform we get a spectrum here. Okay, now look at this as a spectrum information. Of course, we binarize using Asso threshold. These are all inbuilt functions. You just use it. So look at this one. Same 4 images we have considered. These are the 4 images. Now look at this. See, forged. Look at this shape. Look at this shape. For noise, totally different shape. Blur, actually different shape. Now the question is this one, normal and forged. Not really much difference. There is a difference, but not really much difference. But anyway, what we want here, that is what the observation here. So, but definitely, why did you propose this spectrum features and spectrum? Because this is observation. See, look at, there is a difference now. Okay. Yeah, this is what I'm telling. You need to show properly where is the difference. On what basis you are proposing the features? On what basis you are proposing the methodology? Now, of course, since it is very minute difference, it is not so easy to differentiate like taking the shape. Shape is not useful here, so we have already checked that one. So what we do now, we are trying to extract all even minute differences. So for that, what we did here, Kms clustering. That means we take in every white pixels, and of course corresponding to white pixels we get frequency coefficients, and then we apply Kms clustering with k equal to 2. So that means high values will go to one cluster, that is a max cluster, and the low values will go to min cluster. So that means for every white pixels we get 2 clusters. Okay, see now this is the max cluster output, this is the min cluster output. Okay, this is for one spectrum, you are getting 2 clusters. It is not enough, so that is not the feature. Now again, so this is the one shape. Now again, what we did earlier, same thing. Similarly, principal axis or major axis for this one. So this is actually max cluster. Okay, then we are trying to draw horizontal line with respect to principal axis. That means if principal axis is in this direction, we write horizontal line like this. Okay, that means we don't want to propose variant features, invariant features. We don't want features should depend on orientation or rotation, something like this. So that is the reason we are going with the principal axis or major axis. So if major axis is like this, then we are drawing the lines like these. Okay, every line. So similarly for min cluster also. So what we do now, this is just an illustration. So of course on minor axis also. So minor axis means this is the minor axis. Perpendicular to major axis is the minor axis. Again, vertical lines. Okay. So now we are drawing horizontal lines and vertical lines. Okay, that's a parallel lines. Okay, now what is the feature extraction? Okay, principal axis, that's fine now. This is a feature extraction. Now we try to count a number of white pixels on each line. Okay, we have already drawn many horizontal line and vertical lines. We are trying to count number of white pixels on the line. That means we are trying to estimate this distribution only, right? We are trying to understand what is the shape of the distribution. So this is so every line, how many white pixels are there? So every line you are getting some pixels. Just we plot histogram here. Of course, definitely middle line should have a more number of white pixels. That is a normal distribution. Like average intensity, that means every line we try to calculate average. That means in average intensity values, not frequency, average intensity values. So we are going back to the original image and getting the intensity gray values here. So this is a histogram of average intensity values. Okay, we got in 2 histograms now. Now our job is to understand what is the shape of this histogram, and what is the amplitude of amplitude or something. Okay, now this is the idea. So we try to take an average peak. That means so whatever the peaks available, now we just take an average peak. This is the average peak. From the average peak, we are trying to see what is the distance between the last peak and average peak. Average peak is the middle peak. It's not necessarily the middle one, because average, we are going with the average height. Okay, average number of peaks, and we'll take an average. So then again, the difference between from starting point to this point. This is like in a feature. We are trying to extract what is the variation, the shape variations of the distribution. Okay. Similarly, for average this histogram, again we are doing the same thing. Average this one, and finally distance between this point to this point, this point to this point. Like this, we try to extract some features to understand the variations in the distribution, the shape. Okay. I think that's all. So of course here, see, you have something in many features. For every input, you are getting max and min cluster. For max cluster itself, you are getting 2 histograms. For 2 histograms, you are getting horizontal and vertical. Like this, there are many steps here. So finally, we get 20 features per image. Okay, those features will just pass to some, anyway, a CNN and deep learning or any classifier. Even a simple classifier is also okay. But anyway, as I mentioned earlier, if you don't bring any deep learning or CNN, then people will not will not read your paper at all. Just write in one sentence. So this paper is following conventional method, conventional procedure. So this one is so out of scope. So, okay, there is no value for this one. Though you propose something new idea, even you solved a very challenging problem and complex problem, but still people say that when they don't see any deep learning things, so people say that, okay, they are following conventional way and old fashion, so there is no value for that. So they will not even give any comments. Okay, these are the sample results. See, copy paste. This is a copy paste operation, deletion, and this is the insertion. So like this, we use 3 operations to create a data set. Finally, some sample. Then again, standard data set. See, this is what? This is actually handwriting. So we are trying to show our method is robust, which will work for even the like printed number, like in images. And even this, see, this is actually scene text and caption text. Scene text, of course, you don't know this one. Maybe if you know the video, then you can understand what is scene text and what is caption text. Scene text is nothing but a what? Actually part of the image. If you take in the scene images, where you can see some text information, or maybe let us say one video image, you're watching the video, news video, news channel. So there will be some subtitles, right? Subtitles are nothing but what? Caption text. And sometimes you can see some text as a part of the image. That is a scene text information, like in building name, so park name, anything like this. So those are actually scene text. So here the idea is something like this. Caption text is actually tampered text. Scene text is actually original text. So forged text, because caption text is actually the edited text. You're writing, right? Editing. The caption, the subtitles are actually edited text. So when you are editing over video, it is a tampered text. Okay. Yeah, that's one data set. That means, see here, what you have to observe here, not results. See, this is our data set. We propose a method for solving handwriting things, but not these images, not this kind of images. So that's what you need to show. So your method is effective. Yes, doesn't matter. Our method is not just works only on handwriting things. It works even this kind of images, this kind of data set also. Then people understand that, okay, there is a kind of generalization. So it is a generalized method, not like in just a specific method which works only for a specific data set or particular data set. So then again, that should be the drawback of your method. Okay. Yeah, there are many, again, some results and existing methods and different data set also. Anyway, no need to discuss why existing methods poor results and gives poor results, and our proposed method gives better results. That will be there every paper. Nobody proposed method. Nobody propose any method which reports a poor results compared to existing methods. That is impossible. So they try to always achieve better results than existing methods. Of course, if existing method is giving better than proposed method, then they will not include that method at all in the paper. So they will not even mention, they will not even include. So like this, yeah, there will be some kind of forgery. You can say it's a forgery. Okay. This is okay. Just I will try to show this one. This is actually published, not in your journal. It's actually Springer. It's already published. Yeah. You can see, just glance it. No need to understand anything. I already explained. In this work also we propose for a spectrum. So I think should be the last paper, new method for detecting altered text in document image. This is actually a recent one, ICPA or AI. It's already accepted, and even of course we already sent camera ready copy everything. So of course still conference we have not presented. Conference will be on I think in October. In October. Yeah. So this paper is accepted as a oral presentation or oral presentation. Yeah. This is actually here we have what is input here. Here we have taken PDF document. I think PDF, right? What is the title? Yeah, I think PDF. Yes, let me see. Yeah, PDF document. Yeah. See, this is exactly the air ticket problem. So initially, when I was giving introduction, I explained, I gave an example, right? Air ticket problem. This is exactly. Of course, not only air ticket, probably now we can see even real estate property documents also. Many people forge their name also. Even they change even a site number also. Yeah, now PDF document is also no use now. So now people change even PDF document also. Okay. So yeah, there are a lot of scams and a lot of problems. So that's what this problem, this solution is really interesting, and this work is useful. Okay, now this is a PDF document. Actually, PDF document is really challenging compared to even handwriting sometimes, because there will be, you cannot notice even a small changes also. Even handwriting you can notice some changes, but here you cannot notice because it's a printed and the background is white. Background is in a plain background, and see some changes here, some changes. How we can identify this if we change the 4, something in 3? No, you cannot. Of course, this even if you make changes to 5 or 6, no, then definitely it will be a big issue and it will be very problematic. So it will be a disaster. Why? Because so it's something like a site number, right? Site number, if you just site number or something, an amount, right? And your bank check an amount. So just if you change in a 5 with something else, then it's gone. So your property will be somewhere else. Okay. So again, yeah, look at this one. We are trying to propose some DCT coefficients. So look at all the papers. I think just I have listed in 4 or 5, right? Like this, we have still in many other works also, other work work on handwritings, but I did not include because of the shortage of time. So just give 1.5 hour time. So yeah, I'm just trying to cover only these things. So this, see, I'm trying to again, yeah, we're trying to propose some DCT coefficients here. What is the advantage of DCT coefficients? Yeah, this is a framework. Look at this input image now. What is input here? Input actually the PDF document here. Okay, actually what we do here, we take PDF document and finally we convert PDF document to image format because we need an image processing stuff here. So though it is a PDF document, we try to convert to image format. So image, and then we take image as input now. So like this, and we did this work. So see, extracting a DCT coefficients, and again see, I'm trying to analyze the positive and negative coefficients, and of course we'll do some pre-processing step to remove some noise information, and finally we fuse it. Again, look at, I'm coming back to the Canny and Sobel only. So from the Canny and Sobel, so see, Canny and Sobel serve in a two purpose here, solve two problem for me. One is observation. I can easily explain what is the difference between forged and genuine with the Canny and Sobel. That is the one point here. That is the reason I am trying to bring always Canny and Sobel. Once you observe, once you confirm what is the difference between these two, then of course we can propose you anything. Then people believe those things. So without showing any difference, if you just propose some features, nobody believe. Then immediately they understand that you guy and just blindly gave some input and got output. So nobody believe that. Nobody believe the result. Okay. Now again, I'm trying to extract some quality measures, some features here, and finally we pass this one to CNN. And of course, just quality measures are not sufficient here. We're trying to bring some input images. From the input image, you're getting some information from the DCT, residual image, and finally histograms. Anyway, so that means we're trying to use input image also, and frequency domain also, spatial domain also. So we're trying to combine because it's a very tough problem, very challenging problem here. Okay. Now look at now. This is the original. This is the altered now. Okay. But see, when you look at these two, do you think, do you notice any difference here? Is it possible for you to say that this is actually altered, this is actually genuine? No, right? It's impossible. So now look at this one. What is the special property of the DCT coefficient? Of course, I'm not in a DCT guy or signal processing guy to explain what is DCT and all the things, but I know what are the special properties of any DCT, what are the properties of a transform. So we are trying to exploit those properties here. See, now look at this one. What is a DCT property? That is what very interesting point here. So if you understand that one, then yes, your job is over. So your problem is solved. See, DCT always, you look at the DCT property. If it is a original, it's a good image, what happens? See, leftmost corner in the left, and what is this one? Left and top corner, yeah. So you will get in a high value, and slowly when you look at the diagonal values, the value reduces, decreases, and finally look at this bottom rightmost and bottom corner, you'll have a 0 values. That is the beautiful property of an DCT. So that means if it is an original document, I expect this kind of pattern. Here in this corner, I should get a high value. Slowly values decreases, gradually changes, that means decreases, and finally at this point, at this corner, you will get a 0. So that is a property. Now I am trying to check this property now. See, look at now this one. This is actually original. See, actually this is actually 0 coefficient. This is opposite. You look at opposite way. So that means what is happening now? Here you can see some high values, and slowly we're getting low values here. What about here? Compared to these two, these actually, of course, you're getting, but look at there's some difference here. So that is scattered actually, not like in a dense here, scattered. You can see many here also, but here darkness. That means you can, when you study the pattern from here to here, so definitely you can see some difference here. So that is the property I'm trying to explore. Okay. Now look at this one, reconstruct image. This is a reconstruct image, positive coefficients. Okay, this is negative coefficients. Now, so Laplacian, just we try to remove some noisy coefficients, and finally you fuse it. Okay, so this is actually Laplacian over positive coefficient, Laplacian over negative coefficients, and now this is a fused one. This is a fused original and altered. Look at now, what is the difference now? See, this is actually the bright compared to this one. Actually, we lost some information here. We cannot see brightness here. Look at the Canny and Sobel now. Canny, look at this one. This one is see, we cannot even see any shape of the character. We lost even structure of the characters, but at least you can see some, of course, along with some noisy or erratic and noisy edges here, but still we could read at least the text. So that means structure is preserved here, but structure we lost here. We lost in a structure here. Look at so well now. So well again, some brightness and more. We can even structure also. Yes, we can see some structure also. But here, yes, more disconnections here. That's enough for me. Easily we can notice that because of the distortions, because of we lose some quality because maybe because of the distortions. What happens? We are getting some disconnections here. So this is the problem. This is the effect of distortion produced by forgery operations. This one actually original. So because of the original image, see, it's very clear now, very clear. So now there is a big difference. Okay, that's what. Now you just propose your own features. So I think here what we did, yeah, quality features. So what is the quality measures? Quality measures are maybe PSNR, SSIM, MSE, mean square error. Yeah, anyway, now this is important. Once you know this one, now you can extract anything because you already seen what is the difference now. So now it is your job to extract this difference to classify the things. Okay, as I mentioned earlier, so histogram, that means we are trying to use even spatial domain also. So this is histogram of an input images, input of an original and what is this one? Altered. Yeah, this is an altered image. Now this is actually fused image. Histogram of a fused image. See, look at here, we lost information here. There is no information in case of an altered, but here enhanced information is enhanced now. Look at compared to this one. So information is enhanced here, but we lost here. Yes, some information is enhanced, but we lost information here. Okay, so that is a big difference. Now residual. Okay, when you have a difference between these two, again we are trying to extract residual means what? This is actually subtraction between this and this input and fused. So what is the difference between these two? Difference between these two, that results in a residual image. Now of course this is a histogram. So each bin has a one feature vector. So like this, and we try to extract and maybe 25 bins. I think we fixed in 25 bins. So 25 features, that 25 feature vector from each histogram. So we try to pass everything, 25 feature vectors and some quality measures, quality measures also. Yes. Now that's all. So now we see there is one actually standard data set. We found a standard data set. This is a context and ICDR 2018 detection context data set, and this is one more data set. So yeah, see, this is our original data set. This is our data set. Now this is actually ICDR. This is, see, forged. This is actually original and forged, and this is actually IME data set. This is actually international mobile equipment. Something IME number, unique number. So this actually, we worked on this problem because when I saw something in Mysore newspaper, there was one issue actually. So yeah, I don't want to tell the whole story because it will take time. So when I saw those images on newspaper, then immediately we started working on that problem. Yes, we have solved this problem. Yeah, this is actually we call ablation study. I think I don't know, many of you don't know this ablation word. So now, yeah, it's very common now. That means ablation means you're trying to justify or trying to show some effectiveness of each step of your method. So see quality measures. Only quality measures if you use, what is the accuracy, what is the final result, and only fused image, only residual, only the difference between histogram and final proposed method. So that means what I'm saying here, this is very important. That's the reason I'm trying to explain here. If you don't show this one, then what is the use of all the steps? How you can, of course, since it is your method, you are trying to say every step contributes to achieve this final result, but how people can believe that one? So you need to show some experimental results to show that yes, each step contributes. Okay, what is the contribution? What is the contribution? What is the contribution? What is the contribution? When you combine all the things, yes, you should get better contribution. Or sometimes, who knows, this individual step reports highest results, then what? Then you will be in trouble. Then we cannot say this is a proposed method. Then you should say this is the proposed method. Okay. Anyway, that is the reason people expect you to present ablation study in the paper now. Okay, that's, you look at now, I think not a very old paper. If you open any latest paper now, so there will be one section now, ablation study. Okay, so if you don't show that one in the paper, then people immediately suspect, okay, then why did you propose so many steps? What is the use of proposing so many steps? Okay, I think, yeah, that's a limitation. Of course, for every work there will be limitation. So because one cannot say that, so we solved the problem completely or 100%, right? So definitely there will be problems. And look at this one. This is a paper. I think it's not published. Yeah, so these are all actually project students, and he's actually my student. He's here only. Yeah, there's just an I think sent in a camera ready copy. This is the latest one. Okay, I think that's all. Yeah, I think it's a conclusion. Yeah, we discussed on fraud and nationality identification, writer age, and forged handwriting, and then finally altered text detection. Okay, that's all from my side.
Do you have any questions to ask? Okay. Thank you, Dr. Shivakumar, for enriching us. Yeah, yes, sir.
Yeah, okay.
Thank you very much for enriching us by sharing your knowledge. It was very interesting, and we must know. He said he discussed many papers, and he said there are still more, and because of the lack of time, he couldn't do. That means he is more related with papers. There is a reason for that. He is the associate editor of many of the reputed journals, like Journal of Pattern Recognition, CAI, Transactional Intelligence in Technology, ACM, TLLIP, and SMCS. So, such vast or rich experience he is having being the associate editor of these reputed journals. And we are lucky enough to have him as a resource person for today. And on behalf of Assumption College and all of us gathered here, I thank Dr. Shivakumar for spending his valuable time with us in spite of his busy schedule and sharing his knowledge with us.
Madam, someone has some doubt. Probably look at the chat box. Someone is asking something. Maybe if
hello, sir. Myself, Tejaswini.
Yeah. Please proceed. Yeah.
Yes, sir. If I want to, sir, my area of interest is document image processing. Right now, I am doing research on that. So, if you want to make sure the signature is forged or not, whether it is overlapped with any other background. So, what is the minimum data set we require, sir? Is there any limitations for data set to use deep learning or else any kind of CNN architectures?
Data set is the main problem, especially when you start working on forged problem. Even if you take a signature verification also, any forged problem, forgery detection problem, yes, data set is the main problem, because whatever we have a data set, it is all created by us. You cannot get in real data set. So my point is, I think signature verification is a very old problem. Probably because I'm not in a signature verification person, but definitely you can find some standard data set for signature verification, because it's a very old topic. Signature verification is there, signature identification is there.
Not about the verification, sir. I wanted to do in a document oriented part. Just in an idea example, I took that set. But I wanted to know how is there any minimum data set number for to use deep architecture?
Wait, I'll come back to that point. Wait, so just give me some time. Okay. See, when it comes to data set, now people use in a deep learning things. For deep learning, I don't know. Nobody mentioned this is the minimum number of images required for training your deep learning. Nobody has mentioned that one, and there is no proof also, there is no criteria also. But what I believe that in deep learning, unless you feed many number of samples, you cannot get the result. And of course, then it's a waste of using your deep learning. So because idea is very simple. I said deep learning is something like a classifier. If you just think it is a classifier, then you need to have all possible information, all possible cases in your data set. That should be the sample data set, because it is something like you're going with a matching algorithm. So when you have something unknown, automatically it should match with something else. That is a deep learning here. That is a classifier here. That means when you try with a sample, that sample should include all possible cases. This is the question mark here. That is the reason they don't mention what is the
Yes, sir.
minimum here. So they try to have a
Yes, sir.
maximum as much as possible, as many as possible. So that is the reason they're trying to say, okay, now the data set, okay, million or billion, so which includes all possible cases here. So when you give us something unknown, definitely that will match with your known samples. If okay, now
Yes, sir.
let us take this COVID example only. Now COVID is a totally new one. Do you think your deep learning will work for COVID? No, because it's a totally new virus.
No.
Nobody knows. There is no data set.
Yes,
There is
sir.
no sample at all. Now, if you give a
Yes.
COVID data as input for your deep learning will classify as a one of the fever. It will never say it is a COVID.
Yes.
It will just say
COVID
it is a one of the fever. Then gone. That is
Yes,
that is
sir.
the limitation. That is the reason nobody. I think you should go for as many as possible. There is no boundary, but
Okay. Yes,
lower
sir.
limit is impossible, because if you go always, you just go with the many samples only, not really less number of samples.
Okay. Yes, sir. Thank you so much.
Yeah.
Any more questions from anyone? So I thank all the participants for their active participation, and all of you, before leaving, please fill the feedback form. Tomorrow session will be handled by Dr. Parag Kamankar from ABS College, Pune at 2 p.m. on his topic is handwritten script recognition for Indian scripts.